All right, so we are going to go ahead and talk about our rotation notes. Now, this is the third type of transformation that we are going to talk about. We're going to start with looking at the graph and talking about the direction of the graph. Now, all of the rotations we're going to talk about are going to go in 90-degree increments. And there's two directions. There's clockwise, which I'm going to kind of abbreviate as CW. And then there's counterclockwise, which I'm going to abbreviate CCW. All right, so let's take a look at a graph and let's talk about what 90 degrees looks like, 180, 270, and then 360. So clockwise goes in this direction. So we're going to label that clockwise. And it goes in increments of quadrants, so increments of 90 degrees, because each quadrant is a perfect right angle. So each quadrant is 90 degrees. So moving over one quadrant, that's a 90-degree rotation. Moving over two quadrants, that's 180 degrees. Three quadrants is 270 degrees, and then three quadrants is 360 degrees. All right, now if you're going to go counterclockwise, that's going to be the other direction. So it's like the inverse of clockwise, and we're going to call that CCW. Now, when you go counterclockwise, we usually do the degrees. Again, each quadrant is 90 degrees. Counterclockwise, we usually do the degrees as a negative. So one quadrant, that's going to be negative 90 degrees. Two quadrants, it's going to be negative 180. Now, you notice that 180, whether it's clockwise or counterclockwise, it makes no difference. You're still in the same position. Now, three quadrants is going to be negative 270 degrees, and then three quadrants is going to be negative 360 degrees, which really ends up where you started. So kind of take a look at it. 180 and 360, again, makes no difference. Whether you're going clockwise or counterclockwise, you end up in the same location. Keep in mind, each quadrant is 90 degrees. All right, so we're going to take a look at the first triangle, and we're going to kind of do an exploration with the first example. So if you guys can remember, I had you guys kind of stick your patty paper with a little brad on there. So let's kind of read the directions and then see what we're going to do. It says the triangle shown is the pre-image. Let's explore the rotation of 90 degrees clockwise. So I'm going to go ahead and highlight the rotation 90 degrees clockwise. So that means my coordinate is xy. And now let's take a look at what happens 90 degrees clockwise. We can go ahead and highlight that whole thing. Now, moving 90 degrees clockwise is the same as moving 270 degrees counterclockwise. So the opposite direction. So if we take a look at the coordinates, what happens is the x and y end up switching places, and the x value becomes the inverse. Remember, the x value doesn't become negative. We say it's the inverse. So if it was already negative, it would become positive. If it was positive, it would become negative. All right, so we're going to take a look at our triangle. So I'm going to kind of zoom in here. And first I'm going to do it with patty paper, just so you guys can see. So I know some of the triangle, we kind of put the brad through it, so you won't be able to see it, but go ahead and trace what you can see. So there's B, and then there's C. Now, the trick with patty paper and rotations is that you have to draw the full X and Y axis. Now, if you don't do that, then you're going to end up with a rotation that doesn't make any sense, or you're going to get yourself confused. Let me go ahead and trace the triangle from what I can see. All right, and then not only do you have to draw the X and Y axis, but you also need to label it because you're making turns. So if you don't label, you're going to get confused as to how many degrees you ended up turning. So clockwise, remember, is going in this direction. Sometimes I like to draw an arrow on my patty paper so that way I know which direction I'm going to turn it in. And 90 degrees is one full quadrant. So right now, our triangle is in quadrant 1. If I go 90 degrees clockwise, which quadrant will it end up in? It's going to end up in quadrant 4. So I'm going to go ahead and turn it. Now, when you're rotating, you want to make sure that the X and Y axis, they're going to line up. So if I just turn it and estimate like that, right, that's not a complete 90-degree rotation. I want to make sure that my X and my Y axis end up lining up. So as you turn it, you see that your X and your Y axis, like they end up lining up, and then you'll see where your triangle ends up. Okay, now it kind of might be a little bit off, but you do the best that you can to make sure that, you apply a little bit of pressure so that way you can see your triangle underneath. All right, so then my triangle would end up here, and that's going to be C prime. You always want to label. And then my other point, B prime, would be here. All right, so then again, our A point is kind of covered by our brad, but then there you go. You can see your triangle. All right, so if you want to kind of see it a little better, you can take your patty paper off after you do the rotation, but it's not really necessary. So again, 90-degree rotation is one quadrant all the way. Make sure your X and Y axis is labeled. Make sure you draw it on your patty paper. Again, I always like to draw an arrow so I know which direction I'm turning. So basically, my triangle was in quadrant 1. It should end up in quadrant 4. Okay, so let's talk about what we know about the triangles. How is the orientation of the triangle affected by the rotation? So when you look at the first triangle, my pre-image to my rotated triangle, what do we notice about the orientation? Well, it was turned, right? And again, if you look at rotation, another word for rotation is going to be to turn. So we're going to go ahead and write that down. So we're going to say that the triangle is turned. All right, so next question. How is the shape and size of the triangle affected by each rotation? Well, when I made my rotation, I physically took my patty paper, I copied, you make your rotation, and then you paste it, right? So just like we did with the translation, just like we did with the reflection, it's the same thing with the rotation. The shape and the size of the triangle are not affected. So we're going to say that the shape and size are the same. All right, so if they're the same, then we're going to be able to write our congruent statement. So we have triangle ABC is going to be congruent to triangle A prime, B prime, and C prime. Okay, all right, so now we're going to take a look at the next example here. So example number 1. Now we have our triangle, and in this example, it wants us to do a 90 degrees, but we're going to go clockwise. I'm going to kind of fold this patty paper so it's kind of out of the way. And you could do the same if you'd like, or you could trim it. That way it's not kind of overlapping your other paper. So we're going to rotate the triangle 90 degrees clockwise. So same direction, right, as the other one, except in this example, our triangle is kind of in quadrant 4. All right, so I'm going to go ahead and I'm going to trace my triangle. And again, when you're doing your rotation with the patty paper, you're going to make sure your X and Y axis are also traced, and then you want to label them. All right, so 90 degrees clockwise. So I'm going to go one full quadrant clockwise that direction. So I'm going to go ahead and take my patty paper and I'm going to turn it. And I want to just make sure. Now, something I didn't mention in the other example, all of these rotations are done from the origin. So the point of rotation is the origin. So that's why we have the brad in the middle there. So you can also, without the brad, you can put your pencil or your finger right in the origin, and then you can, carefully turn your patty paper. Now, not all rotations are done from the origin, but for 8th grade, everything is done from the origin, so from 0, 0. So when I turn my patty paper, I go ahead and I see there's my G, and then here's my F, right? So I'm going to go on my paper here. Now this is F prime, and then over here is I have my G prime. Okay, and then you can go ahead and connect your coordinates and make your triangle. All right, so that's a 90-degree rotation about the origin, or rotated from the origin. Okay, so now let's answer some of the questions that we have here. So first question, the size of the figure. So what do we know about the size of the figures? Let me kind of zoom in here so it's a little clearer. All right, the size of the figures are, well, again, we copied and pasted, right? So the size of the figures are the same. The shape of the figures are the same. So we can say that the two figures are congruent. All right, so go ahead and pause the video if you want to go ahead and try example number 2 on your own. All right, so let's go ahead and do example 2. And if you already tried it on your own and you pause the video, then you can check your work and see if you did it correctly. So again, I'm going to kind of fold my patty paper out of the way, and let's take a look at example number 2. All right, so now that you've tried example number 2 on your own, I actually want to kind of go up here to the rules and make a correction. So there is a little typo or something missing here. So if you're doing 180-degree rotation, the x is the inverse and so is the y. So go ahead and add that in there. The x and the y would be the inverse. So if you used coordinates and you use that rule, it might be wrong. So you can go ahead and follow along with us. So if I have my quadrilateral here, and if I were to use the rule again, here is my x is the inverse of it again, so is the y, right? So if I look at C is 3 and 2. So if I'm going to do the 180-degree rotation, 3 is negative, 2 is also going to be negative, right? So what I can do is I can go ahead and apply that -3, -2. Well, that's going to be right here. So again, you can do that instead of using patty paper, use the rules, or you can simply do your turn. So that would be a 90-degree rotation, and then there's the 180. Okay, so what do we know about the two figures? Well, we know when we're doing a rotation, the size of the figures are the same, the shape of the figures are the same, the two figures are congruent. Okay, so we can write our congruent statement. We have figure A, B, C, D is going to be congruent to figure A prime, B prime, C prime, and D prime. There you go. So a couple ways you can do rotations. My favorite way to do rotations actually is patty